Hey all, welcome to this week's News and Community Spotlight. To celebrate the 50th anniversary of the Apollo 11 lunar landing and show the potential of using HoloLens 2 to learn and share stories in entirely new ways that have never been possible until now, ILM Chief Creative Officer John Knoll and Andrew Chaikin, space historian and author of Man on the Moon, presented an interactive visualization of the landing at this year's Microsoft Build. While the live demo was postponed due to on-site technical issues, we still encourage you to watch the true-to-life pre-show rehearsal of this exciting project built in Unreal. Created with Unreal Engine 4, Jupiter and Mars, Tigertron's upcoming PlayStation 4 and PSVR title is a neon-soaked underwater utopia focusing on unique gameplay elements such as echolocation to bring its environments to life. No stranger to the glow of bright lights contrasted by darkness, creative director James Mielke draws on his past experience being a scuba diver and developing games such as Child of Eden to create something bold and wondrous for an entirely new audience. We spoke with James alongside artists and programmers from their dev team to discover what they hope to accomplish with the game's message and discuss how Unreal Engine helped them achieve their goals. Stargate Studios of The Walking Dead and CSI knows a thing or two about high-tech film and television production. They turned to Unreal to create visual effects in real time, bringing them right on set and making them part of the filmmaking process. Learn more about how they've achieved this with ThroughView, a set of tools that enables them to shoot in real time while actually seeing CG elements, complete with reflections and lighting integrated in the camera, eliminating the need for green screen setups. Brief Battles from the two-man team at Juicy Cupcake is the culmination of two men leaving their day jobs at a liquor store to pursue indie game development. A side-scrolling brawler, Brief Battles supports a massive lineup of 50 arenas at launch and combines fast-paced action alongside gut-busting humor while keeping things PG. We chatted with one half of Juicy Cupcake, creative lead Andrew Freeth, to find out why they chose the party game genre for their first foray in development. He also discusses where his love for couch co-op games came from, elaborates on how the studio utilized Unreal, and explains what inspired him to weaponize underpants. At this time, I'd like to give a shout out to our top weekly karma earners. Thank you to Every Nun, ICOV, Shadow River, Nebula Games Inc., Norlin, Indie Game Cove, Chakupinator, and T. Sumisaki. These lovely folks are supporting their cohorts on AnswerHub. If you answer questions there, you too could see your name up here. Hope you're ready for a few great spotlights. First up is Midnight Story, a single-player action-adventure RPG that will take you through wild lands, boundless deserts, and a fully explorable steampunk city, all accompanied by a captivating story and fast-paced battle system. Midnight Story has been developed almost entirely by a solo hobbyist developer, so many mad props are due. Be sure to keep an eye on this one. And next up, we have Kin, an atmospheric 3D puzzle platformer that looks fantastic, particularly if you keep in mind that is a 3-day student game jam project. The team of 7 utilized clever shader techniques to streamline their dev process and hopes to continue development on Kin through graduation. Send them love on their page and maybe we'll get to see more from this team. Very, very nice work. And last but not least, Copper Canyon Shootout, the first game from Black Dragon Studios, is a frantic, fast-paced VR shooter set in a Wild West-themed world overrun by robots. You find yourself outnumbered and outgunned against an invasion of corrupted enforcement machines. You must fight your way through the Copper Canyon to rid it of this evil robot horde. You can download it now on Steam, Viveport, and it's coming soon to Oculus. Thanks for joining us for our News and Community Spotlight.
Hi everyone, welcome back to the Unreal Engine live stream. I'm your host Victor Broden, and with me today I've got technical artist Tom Shannon.
Hello.
And we're going to talk a little bit about how to apply programming concepts to blueprints.
Yeah.
I started playing around with a little prototype project here a few days ago, and when I talked to Tom about doing a live stream, we figured why not. Like I had a few mechanics going on, and we thought that this would be something that's good to show off, because I was actually running into some issues that we were able to solve, but we realized that they're not straightforward, and so we would like to share all of this with you.
Yeah, and I think you're in a not too unique position. I think there's a lot of people who have never really don't have CS degrees. They
Right.
aren't programmers by trade, but because blueprints are so accessible and so easy to use, they've started programming. And it can be hard when you've just kind of jumped into a whole new field like that. And blueprints are really accessible and they're really easy, but they're built on C++.
Right.
And they act like C++, which is great because they work with the rest of our systems, and you can extend them with C++, and you can use Blueprint and C right next to each other. It's great, but if you've never done any object-oriented programming, or you've never really dealt with the way C deals with things, you can hit some roadblocks really easily. So it's really easy to make really simple things, but once you start to kind of try and build up a gameplay framework, I think a lot of people who haven't started off in life as programmers quickly go, oh, this is suddenly programming. And Blueprints is weird because it's really a scripting language. It's really intended to build scripting actions, but it's so powerful you can use it as a programming language. So here we are in a space where we've got a lot of non-programmers programming. And so, like you said, I think we're here today to take a look at improving our Blueprint programming by adopting some C++isms, some object-oriented programming concepts, and applying those.
Usually the kind of stuff you go through, it's like one of the first things you do when you study computer science, but it's not so common when you have all the tools to build an entire game, and you might even be able to build a game without knowing any of this.
Yeah, you could probably get by without knowing a lot of this stuff, but knowing it's going to make things a lot easier for you.
Yeah, down the road. And usually it takes you need to do this a few times to realize where your logic falls short, and when you need to start thinking about like scaling your project and having other people work on it and making it stable. And especially for this example, since it's multiplayer, it's even more important that this kind of logic acts as well as it can. And our gameplay framework is already set up to do a lot of those things. And you can use programming concepts with our framework to sort of extend or shape the logic to the extent that you want it. And so that's what we'll be doing today.
Yeah, it can be really hard to figure out, too, where you need to roll your own and where we've already done something that you can just use. So we'll look at that today, kind of how we can look into some of that. So let's get started, shall we? So here is our project. This is the project that Victor's been working on. The elevator pitch is that it's Marble Madness meets Smash Brothers. So eventually we'll hope to have lots and lots of players in here all bashing each other and trying to basically push each other off the edge.
Yep.
And so in its current state, you can see it's very much a prototype. We've got our prototype layout level, and we've got these 4 start areas. And what we want to do is we want to get the game to be to start spawning our characters kind of the way we want to. So if I press play right now, we'll see how it defaults. Right now we're in 2-player split screen. This is being determined by our game instance class, and I'm on the left and Victor's chatting, so he can't. He's on the right there. And the whole idea is that we jump around and we try and knock each other off by boosting and firing things. There's double jumps. You can get up there.
Why not?
Oh, I'm going to shoot you. Where'd you go?
I'm going to shoot you.
Oh, no, I'm going to shoot you. Oh, we're terrible at our own game. That's okay. All right, stop playing the game and get on with the stream. So it's already pretty fun, but as you can see, we've got the idea that we want these 4 classes. And what I really want is I want a 4-player split screen, and we'll adjust that. And what I want is for when each player spawns, for them to spawn on one of these areas and be the class of that area. So we've got fire, ice, grass, and earth. So we want all of our players to spawn in the right place as the right class, and then when they die, they should respawn back in their home area. So if I go ahead and press play right now, you'll see the way that Unreal by default spawns things is it finds all the player player starts in the level, and as each player joins, it randomly selects one and tries to spawn that person there. And when you first start, it'll do a pretty good job of not stacking pawns on top of each other. But when you respawn, it doesn't always do such a great job. So you can see when I die here, it will just randomly choose another spot. And that's not great. I want to always start in the right class. So that's the default behavior, and it works well for testing, but now we want to customize that behavior. So the first thing we're going to want are some ball classes. So we're going to look at the first concept that we're going to talk about today, which is inheritance. So inheritance in object-oriented programming is a parent-child relationship. In inheritance, you have a parent class, and then you can have a child class, and the child class gets all the stuff that the parent gets. So if the parent has functionality and variables and functions, the child gets it. And then the child can add more stuff. The child can get new functions and change stuff. It can override things. It can even do those functions from the parent in a different way, which we'll look at too. And it's worth it to note that the parent doesn't get any of that stuff from the child.
Right.
So, and we'll see how this works with when you cast to objects and you're trying to communicate. It makes it important to put a lot of your functionality into that parent class, or we'll call it our base class, because then you can just reference that base class and do any of that. And then our child classes will have kind of their unique customization. So let's take a look here. In our editor, here's our game here. We've got our content folder here and our Ball Royale. And here's our main gameplay framework classes. We've got our game mode. And the game mode is, of course, the class that determines all the game rules, determines what pawns and player controllers are used, etc. We have our player controller, which in this case we're using mostly to do global input processing, like bringing up main menus, etc. And then we have our player pawn base, which in our case is this. We'll pop this open. It's really just a ball with some helpers and a whole bunch of, variables and come on up here. Get back to my event graph. We've got functions and input, and so we're already pretty well set up here. We have a pretty good working pawn. But this pawn is just a base class. And so there's a couple ways I could approach this. If I wanted to create variations of this pawn, if I didn't understand object-oriented programming, I would think I need to make copies. So I'd make an ice one and I'd change the stuff. But that presents a problem.
And it's very inefficient.
I want them all to jump a little higher. I'd have to go into every class and change that, and tracking that over the length of the project would be awful. And so that's one of the big benefits of inheritance, is that we can just modify one class and it'll cascade to all the child classes. And so in blueprints, to create a child class of any blueprint that you already have is very easy. You just right-click on it and create child blueprint class. And then, of course, we should name it, and we should name this one. There we go. Let's call this one Ice. That will be our first one. And so when I double-click this, this is our child. And you can see that over here, it looks very much the same, but over here in our components, everything says inherited. So these are all the things that came from our parent class. I'll open that real quick. Come here, you. Here's our base class, the parent class. And you can see up here, it inherits as well. This is a child of the character class, which is a child of the actor class, which is a child of object, etc., all the way up. And so it's inheriting the stuff that comes with our character class, which is the capsule and the mesh and the character movement, which is what Victor's using to push the ball around. And then he's gone and added in a camera and the arrows, etc., to help with his gameplay stuff. And so when we create a child of that, we have access to all these, but I couldn't delete this if I wanted to because it's inherited. It's part of the parent. It just doesn't work that way. But I could add another arrow if I
Yep.
wanted. Then the parent wouldn't have that. But in this case, really, we just want to make these a different class. So I'm going to look for our values. And in the ball, it's got a construction script. In the parent class has a construction script that sets the material of our mesh based on a parameter. And so in the child, I can go over to that parameter and let's find ice and assign that. And so you can see in the child's construction script, we don't have the actual construction script. We just have a call to the parent to run the construction script. So this node will run the parent's construction script, and then if we wanted, we could add some additional stuff to it before or after that.
Yeah, we can
construction.
execute it whenever we want to. So
Yeah.
if we want to manipulate some data in the child that the parent is actually executing on, we can do that before the parent's construction script runs.
Right. We could even delete this node and skip the parent's construction script completely.
Yeah.
And so this is, you might be starting to see how this inheritance thing works, where you end up with a lot of really flexible child classes from your parent class. And you don't have to rewrite your functionality over and over again. So now if I'm going to drop these down. If I drag out our ice ball into our level and focus on it, you'll see it's got the ice. And so it's looking like we want it to. Well, let's go ahead and create our others. Just do the same thing. Create a child blueprint class, and this one will be called fire. And then I can also, if I want, I could duplicate the child class, and it will still be a child of its parent. So in this case, we'll want, this one's earth, I think. And then grass, I think, is the last
Yep.
one. So I can duplicate, and I can say grass. And let's go ahead and set those up. Grass, we'll go ahead and set grass. Grass ball. You might have noticed that suddenly UE4 has flipped the script on us and decided, hey, let's open up this blueprint in a different interface. And up at the top, it gives us a little clue as to what's going on. It's a data-only blueprint. So it's figured out that we created this blueprint, and we didn't add any functionality. No new blueprint nodes, no new functionality. We're just changing the variables in it.
And that's nice if you've written all your logic and now you're just doing cosmetic changes, or perhaps the earth ball is a little heavier than like the grass ball, and then you just straight up gets to the class defaults where you can just set that and you don't need to look around.
Yep, it streamlines the interface because quite often you will be making a lot of these variation classes, and it's a lot easier just to come here. If you ever want to add anything else, you can click right here and it'll open the full blueprint editor. And I think once you do that, every time you open that class, it'll open the full blueprint editor.
Yep.
So let's see, we got our grass ball. Let's close those up. We got ice. Let's get fire. And this one is doing this interface, because it wants to show us all of its interfaces. Do this to make my life a little easier. And of course, earth. We'll set that the earth. All right. So now we've got our 4 classes, our 4 ball classes, and they are all children of the base Pong. I'm going to move this over so we can see all of the words. And this gave us grass 1. Let's just fix that. So we've got our base, and then if I double click on any of these, you'll see up here it says parent class is our BP Ball Royale player pawn base, and we can navigate to it and we can open it really easily. So that's a really easy way of doing that. When you're in the parent class, however, the parent class has no understanding of child classes. And that's just part of object-oriented programming, is that child classes understand their parents, but parent classes have no idea how many children they have. They're very bad, very
Thinking-
bad parents and very responsible children, so it works out.
I think it's the opposite in real life.
It is. It's very much the opposite. So I'm going to go ahead and I'm going to save all here real quick because I would hate to lose all of this. All right, so we've got our balls. We've got our various balls. Now we need to get them to spawn up on our areas. And we've got these player starts. And the player start class is just really a very basic class. It has a capsule and an arrow, and that's really all it does. The game, when you spawn, looks for all of them, figures out their position and their rotation, and spawns stuff in there. So they're really just a placeholder. They don't really, I don't think they have any functionality of their own. So what we are going to do is we're going to make our own player start, because I don't want the player just to start right in the middle. It makes it really predictable, really easy to figure out how to mess with someone. I want them to spawn randomly up here. So we're going to just completely make our own player start class. So I'm going to go ahead and right click, make a blueprint class, and I'm going to make an actor. Ooh, that's a big tooltip. It's gotten bigger. So what we're doing now, again, we're picking a parent class. So even if you've never done object-oriented programming, if you've ever done blueprints, you've done object-oriented programming, you've selected a parent, and you know that when you select these different classes, they have different functionality within them, and that's inherited from their parent class. So we want something that we can place in the world, and that is most commonly an actor. So we'll choose actor. We'll call this BP spawn volume. Cool. So we're going to open up the editor. And this is pretty simple. I just want a box so we can determine where the random spawning will happen. So we'll do a box. And I want it to be more than 32 centimeters big. So I'm going to go like 500, 500, 500. Cool. And now we've got an area within we can spawn stuff. So let's figure that out. So let's go back to the level, and I'm just going to drop one of these in here right away. Right on there. And it's kind of big, so I'll scale it down just a bit. Ooh, too small, too big, too small, too big. We'll put that right there. So this is our spawn-in area. So now the code in here is going to be really simple. We're basically going to choose a random spot in here, and then we're going to cast a ray down to see if there's ground under it, and if there is, that'll be our spawn spot.
Easy.
So super quick, we'll build that up here, and we'll do that. Let's make it a function, and by making it a function, we can and we will call this from another class.
Yep.
Which is really cool. So let's call this one find spawn spot. And so what we're going to do is get a reference to the box here, and I am going to get the extents. I'm actually going to cheat and get, we have a nice convenience function here that will apply the scale to the extents for me automatically. If I don't do that, I scaled it in the level, it'll just return 500, 500, 500 and not apply the scale. But we've got this.
And that's a safe way where, say, you're building the core functionality here, and then you have some designers working on it. You don't know if they like to scale or if they like to set the extent.
Right.
And this function will
It'll
just
catch both of them.
Yeah, it will.
Sometimes you have to think 2 steps ahead of your designers. I'm going to move this over just a bit. Too many details. So then within that spot, we want to do a line trace. I'm going to do a line trace. I'll do by channel. That's easy. And we will start at a random spot within this box. So we can actually drag this off and do random. And you'll see we get a bunch of random, and we get random point in bounding box. And we don't want this to go into the origin. We want that to go into the extent. And for the origin, we just want the box's world position. That'll give us the center of that box. That's absolutely not what I want. I want to get the world location, and that will be the origin. And we'll just flip these. Nobody likes cross streams. And so that'll be where we start, because multi-line trace by channel, that's also not the one I want. I just want regular line trace.
Yeah, the multi will actually go through objects.
Line trace by channel. That's the one. Yeah, because it will return all of the objects it hits along that line. And I just want the first one. It's less complex for me. So we've got our start point, which is a random point within our box. And then our end point, we'll just make that 500 units below that. So we just take this vector and we'll add in a vector. Guess we could subtract a vector, but I'm going to add a negative 500 because that's the way I roll. And that'll be our end. And for now, we'll turn on the debug type. And we'll turn on trace complex so that it isn't dealing with collision shells or anything like that. And now if I compile and go back to the event graph, and let's just test. Let's see if this is working. And we'll call this function off of event begin play. Let's go back to our level, and when we press simulate, we should get, there it is. So that's the spot it would have found. And if I keep doing it, you can see each time it gives us another random spot. Might be hard to see, but there's a line with a little dot on it. So that's where we want our spot to be. Let's go back into editor, and I'm just going to double click on this function to open it right up, which is really handy. And so if it successfully finds a point, I want to return that point. So I'm going to get the hit data, and I'm going to do a branch. So we're going to ask, did it hit? And if it did hit, let's return the location. So this is, find spawn spot. I need a return node because I want to return, if it's true, whoop, come here. I want to return the transform for where that spot is. So I'm going to add an output, and it's going to be a transform, maybe. And a transform is, let's call this spawn point. A transform is a rotation, scale, and translation. So I can split this open. I'm going to right click and split that. And I can feed it the location. And we'll just leave these two as they are. So if it doesn't, because this volume could be sticking out somewhere, if it doesn't get a line trace, we want it to run again. And that's pretty easy. So if it doesn't hit, just from false, bring it back over to line trace. And I'm just going to add a reroute node here so this becomes more obvious. So what we're doing is when we ask to find a spot, we'll randomly choose a spot. We'll shoot a ray down. If it hits the ground, we'll say, hey, that's a valid spot, and we'll return that. And if it doesn't, it'll rerun the line trace again. So let's compile and let's make sure. Sure enough, we get a spot there. And just to demonstrate what would happen is if it failed getting spots, which it hopefully should here by doing this, you can see that we get several lines. So it tried 3 times, and on the 3rd try, it successfully found a spot. So cool. We now have this player start class that randomly chooses a spot. So what do we do with that? Well, here is the first big mystery that I think a lot of people run into, and I found many students and game jammers that run across the same problem, where when the game starts and the pawns spawn and all this stuff, it's kind of a black box.
Yeah, it just happens. The game mode
it
just
happens.
takes
Like,
care of it.
oh, and there's all these classes.
And it
and
didn't collide, or like it
Right.
didn't get stuck anywhere.
it just doesn't.
Yeah.
Which is great. And most of the time, especially starting out, that's exactly what you want.
Mm-hmm.
But in this case, we want to be special.
Yep.
And I've done this many ways, and it has taken me many years to find out what I finally have figured out, which is that the game mode class is the class that handles all of the spawning.
Yep.
When the game starts, the game mode spawns all of your helper classes, your HUD, your player controllers. It spawns their pawns and it possesses them. It's the class that handles all of that.
Yeah.
And in Blueprints, you can't really see that unless you know where you're looking. So let's go to our game mode and let's look at where to look. So we're here on the event graph, and you probably know that you can right click and you can find a bunch of the events. So in the game class, you've got a bunch of events here, and those are pretty cool. But there's a bunch of other stuff happening. And if you don't know where to look, you'll never find it. The place is right here. If you go into functions, you'll see it says 31 overridable. That means there are 31 functions from the parent classes that have been allowed to be overridable. You can determine, you can say in your code, this class is too important, people can't mess with this, or this class is designed to be changed and modified. And that's what these classes are. So if we click this override button, you'll see we get a bunch of these functions. And some of them are pretty familiar, like tick. But then you've got other stuff like find player start and choose player start, get default pawn class for controller, etc., etc. And really what these are is this kind of complex chain of functions that happen primarily to kind of start up a first-person shooter game. A multiplayer first-person shooter game. So it makes a bunch of assumptions based on that. And I dug through these and I tried to make it work right, and really I ended up just overriding it all. I figured out that there's one function. Let me make sure I get the right one. It is handle starting new player. So this is the function that kicks off all the other functions.
Yeah.
So when I do this, it gives me an event here. And now, just by placing this here, watch what happens when we press play. I gotta go back to play. Now, we've broken it. So now we no longer get our pawns at all. And it's just using default stuff to randomly choose stuff, but we're not spawning and it's not in the right place. So we've just now broken our game,
Yep.
which is the step in the right direction.
Happens all the time.
Got to break it sometimes to fix it. If it ain't broken, you can't fix it. So let's go back into the game mode and let's make something happen here. So now we've, as you can see, we've kind of overridden the whole spawning thing, which lets us do whatever we want now. And so what we want to do is we want to spawn within these volumes. So let's see here. So let's go ahead and put more of these volumes into our scene here, just so we're not stacking on top of ourselves. We have to do it anyway, so let's do it now. Move that over there. There's our ice somewhere on there. It doesn't have to be precise because it's got some logic. We got our 4 start points. So what we'll do in the game mode is whenever a player starts, we're going to want to assign them to one of these areas. And so the first thing we're going to have to do is collect the areas. And so from here, I'm actually going to do a sequence because I know that I need to do 2 things, one after another, and I like using sequences to keep things organized. So I'm going to do a do once, because I only want this to happen once. So I'm going to get all actors of class, and I'm going to get our spawn volumes. So now I'm going to get an array of our spawn volumes, and I'm going to make that into a variable called my spawn volumes. Cool. So now when the first player joins, it'll do this, because it'll only do this once. So when the first player joins, it'll give our game mode an array of all these actors. So then next, what we want to do is we want to assign each player to one of those volumes. And we've got 4 volumes, and we have 4-player split screen. Very convenient. It's almost like we set that up on purpose. So what we're going to do is I'm going to use the player ID to assign them to each one of those 4 volumes. So from here, when this event calls, it calls right after it creates the player controller. So we're
Okay.
not overriding creating the player controller. It'll create our player controller, and then it just leaves it there. Like, what do you want to do?
You may want to show how we're actually creating the extra player controllers, just so that everyone.
Oh, yeah. So if you've never done split screen before, you should, because it's great.
It's fun.
It's so easy too. So let's see. That is, where is that? Is that
That's in the game mode, actually.
Okay. So that's actually right here. On begin play, we've got handle local multiplayer. And really all it's doing is it's asking our game instance if it is indeed a local multiplayer game. And then it's asking how many players we have. And then for each additional player, so we're starting at index 2,
Yeah.
because it always spawns the first one. For each additional player, we call this right here,
Create player.
create player. And you can call this 3 more times, and it creates split screen for you.
Yep.
And it's just that easy. And every time you call create player, it calls our handle starting new player.
Yeah.
And so every time that calls, that'll get called. And it's really easy. There's some settings in project settings to determine horizontal, vertical. And it's a great way of testing out multiplayer stuff because you don't have to deal with replication. You just get 4 players and they work. You do have to deal with making sure that your data for your players is stored in the right place. You can't just throw everything into the game mode, because then it'll start getting messy. So it's a good place to start learning how to encapsulate your code into your different classes so that when you have 4 players, it's not just data fighting itself. Without the added complexity of networking and
Replication.
dealing with authorities and clients and stuff. So it's a good step to getting multiplayer working without having to tackle the whole internet hard part
Yeah.
of it.
And latency and
Latency and
Yeah.
all that fun stuff that Victor is
that I'm commenting.
that he's having
Yeah.
fun with right now. So that's why we've chosen also to do this with split screen, so that we could remove some of the complexity of the networking side and really just focus on how we're solving the spawning problem. All right, so when each one of those players is added, it'll call this. When the first one's added, it'll make an array of our spawn volumes. And then really we just want to tell the spawning we want to spawn upon and possess it, because we are in charge of doing
Right.
that now.
The game mode is just not going to call the function that normally does that.
Right. And what it does give us, though, is our new player controller, so we can work with our player controller. So the first thing I want to do is find out the player controller ID. And so the player controller ID is just what player number you are, and it starts at 0. So the first player is player 0, and each time you add someone, you got 1, 2, and 3. And so in this case, we can use that to look into our array of start points and assign them based on that. Now, I have learned another cool trick that I use all the time when dealing with arrays, and that is, so I'm going to grab my array, and I'm going to ask what the length is, because if I ask this array, for an entry that it doesn't have, it can cause an error, and in a package game, it can even crash the game. It's one of the really good ways you can crash a Blueprint project is by doing a get on an array that's empty. So we want to make sure we're getting a valid index. And to do that, there's this great node called modulo. So from so we're going to get the player ID, and we're going to modulo it. And you can type in mod, or you can type in the %, and it comes up with %. And it's kind of weird,
Yeah.
because most people think you're going to get you're going to divide by 100. Why is that? We're not. Modulo is basically it loops. So you feed it any number, any integer, and then you give it kind of a maximum number.
Yeah.
And if it goes over that, so if I feed it 4, or I tell it 5 modulo 4, it'll return 1.
Yeah.
5, 6 modulo 4 will return 2, and it'll just keep looping. So it'll never return a number that's outside the length. So by doing this, even if I've got 100 players, it'll always choose something between 0 and 3, which is really handy.
Yeah, it means we don't have to reset the integer that we're using for how many times we call this. It will just automatically do it. It's great for UI when you're clicking like
Yep.
go to the right, and then you want
And
it to
then
go
it
back.
goes all the way back.
Uh-huh.
Did it? Yeah, I think we've all written that horrible code. Where
Yes,
we've
we have.
tested
And then we're
if
on
it is
Answer Hub and-
greater or equals then do this. And this is something that someone who goes to CS school learns in like week 3.
Yeah.
And those of us that don't learn in year 6
Mm-hmm.
of doing it. So hopefully this speeds up some of your learning here. So then we're going to just get from our spawn volumes, we're going to get. We're going to get a copy. And we're going to use that as our index. And so this returns a reference to a spawn volume object. And by having a reference, which is another C++ism or object-oriented ism, it means that I have access to everything that object can do. So I have access to all the variables in there. I could tell it to move somewhere. I can also run the function that we built in there. So that's what I want to do, because I want to get that spawn point. And so I can run that function. So it's find spawn spot. And so now we'll hook that up to our then. So now what's going to happen is when the first player joins, it'll make that array. And then it'll go and find a spawn volume for them to spawn in. And it will ask for a spawn point, which it should, if it finds one, return one. And then we can spawn our pawn. That's not how we do it.
We want to spawn a
actor.
pawn, but
So we spawn actor from class. And this is how you create any
anything,
actor.
yeah.
Okay. This is the one node to make actors using blueprints. So it even gets its own special icon. That's how special this node is. And it asks for a couple things. It wants to know what class, what actor. Is it a static mesh? Is it a ball? Is it whatever? And then it wants to know the transform, which is convenient because we're returning that.
look at that.
Look at that. But you know what? We're not returning the class. And so I want each one of those spawn points to define what
Okay.
class will possibly spawn in there. So let's go back real quick to the spawn volume, and let's add something that we can use to set that up. And what I'm going to do is I'm just going to add a variable, and let's call this ball class. And I'll hit enter to name it. And then for the variable type over here, I'm going to do something pretty cool. So I'm going to look for ball. And you can see I'll get all of my ball classes here. But what I want is the base. And I don't want an object. Most of the time when you're doing blueprints, you'll just click and it'll give you the blue object reference. That means it's referencing an individual actor
instance
or an
of that.
individual asset, a material or a static mesh actor. In this case, it just wants to know what class is available. So I'm going to do a class reference to the base, and you'll see what happens here. And then I'm going to make it instance editable and expose on spawn. I don't think I actually need that. But you'll see down here in my default value, I now have a list of all of those child classes,
Yeah.
including the base class, but that's okay. But so if I were to make more and more and more child classes, they'd just appear on this list and be available. I could even make child classes of my child classes, and they would show up in this list.
And now you could actually set that data type to be actor and also fill in
Yeah, and it would give
select
you-
the pawns. But since we specifically know that we want to spawn a pawn,
This type of
this
pawn.
type of pawn that the logic exists in, we want to preface the data and saying that nope, it's only going to be for this type of class.
Right.
And that's a good way to prepare your functions for designers as well, so that they sort of have a context sensitive version of what kind of class they can
Right.
use here.
So this way we can make sure that they're not throwing something in that they
Yeah.
shouldn't be. Yeah. So now in our level, on each one of our spawn volumes in the details, I can set the ball class. So this one should be fire because of that fire texture. And this one should be ice, of course, because of the ice texture. This one is earth. And this one is grass. Like that. So now our volumes know what type of ball they should spawn. And we've gotten pretty good here in our game mode. Make sure I'm in my game mode. Working on one low-res monitor is a special kind of challenge. So let's see here. So now these volumes have a new bit of data that we can get from here. So we're using find spawn spot, and now we can also get ball class. So now we can access the ball class and pipe that right in there. So now, drum roll please. There's no way this is going to work. There's two people doing a drum roll. It didn't work. Too many drum rolls.
Too many drum rolls.
No drum rolls next time, please.
More cowbell.
Oh, of course. Well, one thing we need to do. So we've spawned these actors. We need to possess them.
Right. We need to tell that, hey, the player controller, which is actually the actor that takes our button input and do something with it, we need to tell it that this is the pawn that you're supposed to control.
Right. That's the actor that it's passing its input onto. I like to refer to the player controller as the player's ghost in the world. That's only because it can possess and unpossess things.
Okay.
And then when it's unpossessed, it has no form, but it can move around and it can possess other things. So I think a ghost.
I've called it the brain.
The
I think is
brain?
what I've,
Yeah.
yeah.
But
That's not entirely true because you can also write your sort of the logic of what's going to happen and the inputs in your pawn, which is most commonly when you start out.
Yep.
In this case here, I've actually added some generic things that are like opening main menu.
Yeah.
That kind of input lives in the player controller because what's nice about that is that the player can actually have input even though we haven't spawned a pawn for him yet.
Right. Or if they change pawns.
Right. Yeah. Or if they're in a menu and for some reason you did spawn a. Oh, never mind. That would be strange. But there are scenarios. Yeah, it's good to think about the player control. There always needs to be a player controller for you to have input at runtime.
Right.
And so generic inputs are nice to place there, but more gameplay specific, like the ball jumping, for example.
Right.
That should probably live inside the
In
pawn.
the pawn. And that's something that's often a philosophical sort of thing. You can build
Yeah.
a game with all your input in one or the other, but you'll probably run into some issues one way or another. So typically speaking, you're right. That's really the design pattern that we work with is we have most of our generic input stuff processing in the player controller, so bringing up main menus, like you said, if they've died and their pawn is gone, they still need to be able to respawn or whatever.
Yeah, or
Launching HUDs are often a good
Change
place for
settings
that.
while they're waiting for the next match to start.
Exactly.
Or, yeah.
And then all the pawn-specific stuff is handled in the pawn. And that way you can have a game where you're a rolling ball 1 minute and you're a fighter jet the next,
Yep.
and the same inputs will be processed very differently. And so the old way to do that would be to throw all that in the player controller and have a big if statement. If I'm flying a plane, do this stuff. If I'm doing that. But the more writer way of doing it is by using encapsulation and putting those into those individual classes. And
Yeah,
see.
compartmentalize
I mean, they
it.
would both run the same
Yeah,
way
yeah, it
at
would.
the end, but by compartmentalizing that functionality, it's a lot easier to maintain in the long run.
Yeah, and
and
you-
if you're working on a team, it's a lot easier
Yep.
that way because one person can work on ice ball and one person can work on fireball. There isn't just this one class that contains all the instructions for the game.
Yeah.
So let's hopefully now possess this. And to do that, we get our player controller, a reference to our player controller, which is coming in here. And it's got a command that's called, predictably, possess. I'll drag that on over. Whee! And that has a target. So who is possessing the pawn? And the pawn is this actor that we've just spawned. Now,
Should we do one drum roll?
please. One drum roll. It got worse, Victor.
What
No
do we
drum
do?
rolls next time.
Okay, none at all.
It's because it's on a live stream. So I'm starting
Break all
here.
the things.
All right, let's go real quick. Let's take a look. We should be possessing. We're finding a spawn spot. Make sure we're returning the right location.
I didn't actually see when you drew the line trace line,
All right,
making sure that that is,
let's do this.
yeah.
Let's go ahead and we will just break that for now and make sure everything else is happening. I forgot we have the extra window.
Here we go.
So it's finding spawn spots.
It could be that it's trying to spawn inside the base, and since the spawn actor default collision behavior is set to, so we'd actually want it to spawn. So that's actually something that
So
you can.
what we can do is we can just, the location, we can just give it some height. So rather than trying to spawn right on the surface, we'll try and spawn up in the air just a bit.
And the player starts origin is actually at the center of the capsule.
That's why we need to move our spawn
Mhm.
up. Yeah, there we go. So this should now work. And it was actually in my notes to do that. Glad you remembered. All right.
No drum roll, just to make sure.
Look at that. We should have done
we
a drum
go.
roll because it worked.
Oh, all right. Next time.
Here, let's set this to 4 players now, and now all 4 players should. So that's in our
The game instance.
game instance.
And I want to just point out that the local multiplayer pool, as well as the number of local players, that's something that I set up. It doesn't come by default.
That's right.
And I'm using the game instance just to keep that that data persistent between levels. So you can load another level, but once you've set up the game to be 4 players locally, it will just know it no matter which level you go through. Because the game instance is actually a persistent class. It doesn't get destroyed and then spawned again like the player controllers and the pawn does by default.
Yeah.
It will persist throughout the game.
It is, in fact, the only class
It is.
that persists through the whole game. So if you ever need to persist data between levels, the game instance is your class.
Mm-hmm.
Oh, it's going to autosave.
And also a little note there, if you're doing network multiplayer, it doesn't live on the server.
Right. It's only on the client.
Yes.
And so that's worth it to note, too, that if you see anything on the stream in one of these classes and you open up the class and go, that's not there, that's because we are looking at a game that's in development.
Yeah.
It's a prototype game right now. So there's stuff hanging out. There's functions that aren't being used. So
To-dos. and-
we apologize for it being real. So now we should have 4 pawns that spawn on their pillar and in their right class. See what happens? No drum rolls.
No
It
drum
works.
rolls,
Drum
yeah.
rolls are the worst.
Maybe you should get a trumpet or something.
So now we can come around and try and get each other. Or ourselves. Ooh, I almost got you.
Yeah, almost. Try Dave. Controller's not as easy as mouse and keyboard. I'll work
So
on
I want to show the last problem that we've got, because this is working.
Yeah.
Yay. Is now if I die, I'm back to using player starts, and I'm not starting where I'm supposed to be starting.
Nope.
That guy's really well camouflaged, though.
take him out.
Take him out. And you'll see both of us start in the wrong spot. So now we need to make it so that when we die, we follow kind of the same logic. And that's pretty straightforward for us. So we've already got actually a function in the game mode that's handling that. Right now it's just got a move player to random start. So when we die, which is just us reaching a certain altitude, it calls this function.
Which I wrote.
Which Victor wrote, and
Yeah.
I'm going to get rid of. Sorry.
That's
It's a good function, but it's not the function we need.
nope.
So really what we're going to do is we're going to steal a little bit of functionality from his, because it's got this right here, which is stopping the movement,
Yeah,
because the ball is falling, and if
Mhm.
we teleport it right back, it'll maintain its momentum, which
Yep.
is really cool if you're making Portal. But in our case, we want that ball not to be falling so fast when it respawns. So stop movement immediately with the character movement component accomplishes that, and I've just selected and copied, and I'm going to paste because I don't want to click too much more. And I'm going to tell it that I want the pawn to stop. And then, so this was kind of a challenge for me. I couldn't figure out, when this pawn dies, how does it know where to start?
Mm-hmm.
Because the pawn doesn't know where to start. It doesn't know who spawned it. So I figured, well, why don't I just tell the pawn, when it spawns, this is your home.
Uh-huh.
And so when the pawn needs to respawn, it can just say, where's my home? And it can go home. So to do that, we're gonna look at another object-orientedness.
Yay.
So we're gonna go to the parent class of the ball, and we're gonna add a variable to it. And all the child classes will have that variable now, and we can utilize that. So we don't have to go into each one of those classes and add this variable in. We'll do it once, and they all get it. So we'll go to our folder here, and we'll go to our base pawn class. And what we want is a new variable in here, and we'll call this my home, because that just sounds sad, pathetic. So, and this will be a spawn volume. So we can reference our spawn volume objects, and when you create a blueprint class, UE4 is aware of it and shows up in menus and stuff. So we can use this just like any variable. We can make a variable our blueprint. And so now it's got this, and we'll make it editable, and we'll expose on spawn. And this is really cool what happens here. So I'm going to compile, and I'm actually going to save this. And now in our game mode, get rid of this game instance because it's confusing me. When we spawn, we have the spawn actor here. If I right click and I refresh the node, you'll see that my home variable came right in there.
It's been exposed.
It's been exposed, and so now I can just tell it, hey, this is where you started. And so now when those balls spawn, they've got this reference to where they came from.
Mhm.
And so now when they have to respawn, we can just ask them,
What's your home?
get my home. And then we can do kind of similar function here. We can get a random spawn spot. I forgot what find. I need to find my spawn spot. Whoop. And then we want our pawn to move there. Set actor transform. And we just hook that up like that. And now, without any drum rolls, please. Whoa, I'm right on the edge. Oh, you gotta fall.
And there's a little bit of
And I come right back. And so every time we die, we should always appear back on our respective spots. Not home pods. We don't own the rights to that.
and we're dropping slightly because we're spawning a little bit above, but we are actually stopping movement. Otherwise, you'd see us go really fast and possibly even go through
Yep.
if we didn't stop the movement there. I don't like grass. It's gonna earth. I also need to go.
What about wind and heart?
Well, I haven't gotten that
Captain
far into the
Planet is
design yet.
upset. Not acceptable.
That would be too many homes for us.
So, I mean, and that's kind of we've solved our issue here. So there's so many ways you could go about this, but really this is a really good way because you're not going through that whole spawning process and then overriding it.
Yeah.
Which can cause all sorts of issues down the road where whenever there's something happening in code that you're not in full control of, down the road it can come and bite you. And so I always like to really have a good idea of what's going on so that I can decide whether I'm going to use what Unreal exposes and what's already there, or if I need to make it exactly the way I need to. Because so often there's stuff in Unreal that's already done.
Yeah.
And you don't have to reinvent the wheel, but oftentimes you do. And that's really cool how flexible. Once you understand how to override those default functions, it becomes much more flexible.
And it's worth pointing out that you can also override any function in any child that you make yourself. It's not only the classes that are provided by default, right? It's
Right.
just common functionality in programming languages that you can override functions from children.
Yeah. And that's even a, like, for example, if I wanted to make a generic attack, so every time I hit spacebar, I attack, I could, in the base class, just put in a stub, which you'll hear that term is function stubs. If you ever read through source code in C++, you'll often find just stub function for
Okay.
overriding. They're literally just there so that you can override them later. They're just empty functions that are like, hey, at this point, maybe you'd want something to happen. If you're ever really curious about all this, of course, I don't know if this machine has Visual Studio installed.
I believe it does.
But of course, the best way is just to click on the parent class and load up Visual Studio. And it's going to, oh, look, it loaded
Yeah,
it
it
up.
worked.
So, and then you can go in and you can find all of these functions. This is probably a little intimidating to some people when they just see a wall of code like this. But you can look for these functions. So when you find the function, what I'll do is I'll open up the code and I'll search for it. I'll do find, let's see if there's anything with spawn. And then there's all of this really well documented comments on almost all of the functions. We've done a really good job. So at least you can follow through here and you can see how one function calls another and what our intentions for those functions are. And this isn't so exposed in the documentation, etc. The best place to find this stuff is right in the C++ classes.
And you don't need Visual Studio to run a binary version of the engine, but
Nope.
it's really handy to have it installed and even generate project files for your binary project. Because of this, you can just either click go to parent class, or you can double click a function and Visual Studio will bring it up. And at least if you have an idea what sort of the blueprint version of it does, and then going over to C++ and trying to figure out what it's actually doing, you have a little bit more of an idea instead of just opening up random classes and trying to figure out what's going on.
Because like I said, some of those functions you'll open in here and you'll find out it is literally just empty. And it just gets called because we know that this is a common place where something will happen in gameplay, or it's a place where it's happened for our previous game, so we've exposed it, and now it's just kind of waiting for you to use it. So, yeah.
That's great. We have a couple of questions. Some of them that I hope that you know the answers to because I don't.
We'll see.
We'll see. We'll see.
I pretend to be a programmer, but I went to
That's-
art school.
Yeah, I'm a
I
musician.
read some I read some programming books and I hang out with programmers, so I pretend to speak their language.
That's when you learn a
sometimes.
lot. Or you go deep into the trenches of game development and you discover all the things you have to learn because
Yeah.
you're trying to accomplish something that you need to know a little bit.
You need to know a little bit about a little bit of everything.
Yeah, especially when it comes to multiplayer. I would there's a lot going on there that Unreal makes it very easy to get started, and you can simulate several players inside the editor, and looks like everything is working the way it's supposed to. But on a network in the wild west of the internet, things are a little bit different.
And I think, was it Zach or Wes that did a networking series?
Wes
here on
did
the
a
stage?
series on how to use Steam to connect several clients to a host that is a listen server, right? So one player actually opens up his instance of the game to be the server, and then other players can connect to him as clients. Yeah, it's like a 24 series of 24 videos. I
Yeah.
think that's up on our YouTube
So,
page.
so not quite an hour, Thursday stream thing, but there's if you are interested in extending your game to be multiplayer, Blueprints still works. I believe
Yeah,
your goal is to make this entire game in Blueprint.
It is, yeah, and
including multiplayer, local. I think you're even hoping for like mobile, like
I'm
Android
hoping-
split screen, or
Yeah,
something
yeah.
crazy like that.
we'll see.
We'll see.
Yeah, we'll see what is possible to be accomplished in Blueprints. But that's sort of the goal I have, just to use the tools that are provided, and to not try to get too deep into the trenches of things, and then also shape the project around what is possible. That's just because I've shipped games, multiplayer games, entirely built in Blueprints. A couple of plugins, yes, to handle some things that you don't have to rewrite because someone has already done it and uploaded it to the marketplace.
Right.
And so it is absolutely possible. You can do tons of optimizations in Blueprints. You can nativize them. We have quantized vector. We can quantize vectors in Blueprints. Like there are a lot of things there that allow you to make efficient multiplayer games that works in a networked environment with even high latency.
It's pretty remarkable.
Yeah, it is. I
And,
never,
and it's that sort of functionality that really blurs the line between Blueprints bringing a scripting language and being a programming language, because they are powerful enough to write a multiplayer video game in, but they still have the limitation of being precompiled C++ code. So you can't ever do anything that's not part of the Blueprint
Yeah.
API. It's locked in. Of course, you can extend it with C++ on your own, but if you're not going there, there are some limits to Blueprints, but every release, that limit gets pushed.
yeah, I
further and
just
further
frequently
back.
see the library getting bigger in terms of what we just have off of the default branch of the engine, and so it's empowering. Is what it is. It gives you the power to do things that would have been a little harder if you didn't have all the functionality of Blueprints.
Yeah.
Um,
And look at us, artists and musicians
artists,
making
making
games.
video games. That's pretty crazy, and a lot of fun, and it helps you due to the fact that I think you might have mentioned it, but due to the fact that it is C++ in the back, and you're actually programming logic, and in the same way that you would have done it in C++.
Yeah,
and so it allows
actually,
you to understand how you would have done it in C++, not necessarily the syntax
Yeah.
or working with pointers or anything like that.
But that's an important design decision that we've made with Blueprints, to keep them as close to C++ as possible, so that if you do make something in Blueprints and you decide it needs to be more performant, or it needs something that Blueprints doesn't expose, you can hand it to a programmer.
Throw it to the program.
And they can follow that structure. They can't obviously copy paste it, but it follows the right structure, so they can see what functions to make, what variables to make. They can make them the same names. It's very comfortable for them to see. In fact, Zach Parrish made a slide at one point, and what he pointed out, if we can go back, fade, yes, brilliant. Over here in our Blueprint, is kind of like the header file in a C++. So
Okay.
over here in the components in my blueprint, you define your functions, you define your variables, you say what type they are. If you're a C++ programmer, this is what goes into the .h, the header file.
Mm-hmm.
And then over here in your event graph is like your .cpp file. This is where all the actual code goes. And then the construct is like the init or the construct. So even the interface, when you look at it, becomes much more like C++, being divided between a header and the functionality.
Yeah, and if you do want to know more about that, because you're like, should I do it in the construction script? Should it be on begin play? You can actually read about like how a C++, how our C++ classes work, and understand that a little bit better, and where you're supposed to do what, essentially.
Yeah. Any more questions?
Yeah. So there was a question that I don't. Will we be covering structure and framework, and which loads first when a game starts, like instance, mode, state? I don't have a straight answer, but I can tell you how to figure that out, which is essentially, and this is good to know. You know, it might not only be these classes, but it could be other classes that you're curious about how they work, and that's just print strings. See when they enter breakpoints on like begin play, or the construction script might be even better.
Yeah.
On all those classes, and then you can add some breakpoints, hit play, and see which one gets hit first, which one comes after.
I do know that when your game loads for the first time, the game instance is the first class to be instantiated.
Okay.
So it instantiates as soon as your game loads, and it doesn't unload until you hit quit or
When
it
you terminate,
crashes or
yeah.
however. So it's there from beginning to end, which is great. So you can put data in there, and it can be accessible from start to finish. When you load a level, the level loads, and then I believe the first thing that loads from the framework classes is the game mode. So the game mode is the first thing to load because it's the thing that tells the game all the other classes. So the game mode loads first. For each character or each player, you get a player controller. The game mode spawns a player controller. And then the game mode, possibly, as we've seen, will spawn possibly a pawn, will spawn the HUD, etc., the other helper classes along with that. Each player, I believe, I think it's the game mode, also spawns the
Game state, player
and
state,
all of that.
yeah.
But most importantly, the game mode loads first. The game instance is always there. The game mode loads first when the level loads, and then player controllers and all the helper stuff. Kind of, that all you'd have to really print screen because it is kind of a web of functions calling each other to make all this
Yeah,
stuff happen.
and it's important to notice that it's built for multiplayer.
It is.
And so some of the classes only lives on the server, some of them only lives on the client. And that concept, if you're making a multiplayer game, you need to know that because you can't write logic on the server that the client wants to run, for example.
Right. And that's based on our years of making multiplayer games.
Yeah.
But if you're making a single player game, it can be a little overwhelming. Really, in a single player game, you need a game mode. That's the only class you really have to have. That's the minimum standard.
Yeah.
Like a main menu, for example, can just be a main menu, a game mode. It'll still spawn a pawn and a character, but you might not define them. But for a single player, you need a game mode and a pawn. That's really the
Player
minimum
controller.
you need.
Yeah.
That's even questionable.
Could you?
I wouldn't go that way. I would almost always make a player controller. But if you are making a game that only ever has one pawn that can never die or be changed, you can put all that player controller stuff into that pawn and it would be safe. Again, if you ever make any changes to your design, that's going to be a hard change to move back. But yeah, I mean, if you're a student and you're just learning Unreal, those classes can just overwhelm you because there's so many really to get started. And even if you start a new project and use the templates, that's the design pattern we've used for most of those.
Okay.
Is almost all of the input processing, everything's done in the pawn. Most of the player controllers have no code in them whatsoever.
It's just the
they're
default,
there.
the default one that isn't even a Blueprint
Yeah.
player controller. It's just a C++ player
It's just-
controller.
it just points to the default.
Yeah, and
So-
whenever you make a game mode, that player controller will always be there.
Yeah. So yeah, if you are making single player or split screen, all of those additional classes are really there for multiplayer. So don't let those get in your way.
No.
And also all of this stuff that we've shown is kind of best practices, but like I said, there's tons of ways to go about this stuff, and there's, I'm sure right now, programmers shaking their fist at us, going, "That's totally not the way I."
They
do
had
it."
some thoughts about the for loop on the on the line trace there. They definitely.
Oh, I've got some thoughts too. Anytime I see a wire going back, I'm like, "There's probably a better way to do it," but during a stream and a learning
that,
session.
and it's also worth to notice that there's very, depending on the scope of your project and what you're trying to do, pre-optimizing can be a blocker that doesn't get you forward with your progress of your project as much as you would if you're just like, oh, I mean, it's only going to loop about 6 times, right? It's like,
Right.
it's not going to add any significant amount of impact.
Exactly. Like that's exactly the sort of where there best practices is a term I use really loosely because, for example, that for loop, like you're saying, that's probably not best practices. But in this case, I know that my design is set.
Yeah.
So it's safe. There's no way to break it. Not within this design. I can think of 12 ways off the top of my head. If I changed my design, it would break. But in this case, it works and it gets the job done, and we get to go have pizza. So
Yeah.
it's the difference between spending another hour going, what is the best way to do this?
And I think about that a lot, and sometimes I just have to tell myself that, like, nope, you have a solution.
What's
Just,
the phrase? Perfect is the enemy of good.
huh. Yeah, or enemy of shipping. Could be another one. They were wondering if there's any overhead to or what the overhead of a data-only blueprint is. And I actually don't think there's no difference. It's just how we display it in the editor, right?
Yeah. So it'll still be running any of the same functions. If you put in the parent class, if you loaded up tick full of horrible stuff, all of the child classes would have all that horrible stuff on tick too.
Yeah.
Even though you don't see it in the interface. And that is something, like if you make a new game mode class, it looks blank, but it still does all that game mode stuff.
Right, it
in the
has
background.
everything that
So
it...
You can't see it, but it's still doing it.
They were wondering, since we're sort of on the topic, when we should use inheritance versus using interfaces. And they sort of coexist.
And that's a really good question. In this case, we're using they coexist, and in this case, we're using direct communication.
And it works fine when it's like the pawn, because it's
Right.
such a core pillar of our logic.
Yeah. So I think the advice is you can cast and do direct references within your base classes.
Yes.
So for example, I avoided, in this example, I made a design decision to avoid telling my base classes all about all those child actors. And I did that by just telling each one of those individual spawn points about those classes. So if I had a level that only used one class, it would only load into memory that one class. And that's intermediate to advanced sort of stuff. But so typically I'll only use casting and direct in between the core classes.
Anything that should be in your core.
Yep.
Folder.
Anything that's a child class will typically be through an interface, or like I said, you can add functionality into the base class. So you can add a stub function, call that stub function from the base class, it'll call, and then that child class can do something unique with it. And then interfaces I use pretty much anywhere where I want a generic interaction between two actors.
And you don't want to know...
Right, I don't want to know what the other actor is. I want to just walk up to anything and tell it to do something. And if it does it, it does. If it doesn't, it doesn't. A great example I like to use is hit E to interact. So I can just go up to anything, hit E, and I'm just telling it interact. And if I interact with keyboard, it types. If I interact with the chair, it does nothing. So it's a safe way to bring stuff up, whereas direct casting lets me access the functionality of that thing. So for example, I wanted to use the spawn volume to find a new spawn point. So in that case, an interface wouldn't work.
Right.
Not well. It would be really funky to
You would have
trigger the the volume to find a spot, but then how does the volume tell me now that I've got that data? So in this case, I want to directly reference and tell it to do something and to give me data back.
There's a great tutorial that Zach Parrish did on the live stream 2 or maybe 3 years ago. That's called Blueprint Communication.
Yep.
I would very much suggest you watch that video. He walks over casting, blueprint and interfaces, and event dispatchers, and it really cleared it up for me when I
Yeah.
watched it, sort of how it was designed, how all of those things were designed to be used in blueprints.
Yeah.
It's a wealth of resource.
Yeah, that stream I have watched several times
Yes.
over my years, because oftentimes I need kind of a refresher of like, or just recently I haven't used event dispatchers in some time for whatever reason. None of the stuff I was making needed it, and I was like, I forgot how to use event dispatchers.
Yeah, and
So I
then-
fired up the video. Oh, okay, I get it.
There we go.
It's totally a go-to.
Yeah, do I
for-
make event? Do I create event? Well,
Yeah.
what it, yeah.
who finds it? And,
Mhm.
yeah, don't get me started on communication.
They're wondering if there's worth to following some sort of design patterns while developing blueprints. Maybe there's something especially useful.
I mean, we've discussed a bunch of them.
Yeah.
I think the one that helps me the most is, I guess, what they call components or encapsulation. So, and that's making it so each actor, each class does the things that that class would do. For example, with us, we could have added this, the code to find the spot within a volume to the game mode.
Mhm.
The game mode could have said, okay, I want a volume and I want to find a spot in that volume. And that would work. It would return the same stuff. But the best design pattern is instead to put that into the volume, because you would ask the volume. You know, in the real world, that's the way object-oriented programming, you're supposed to kind of look at things in the real world. Like, if I had a light switch and I flipped it, would I make the light turn off?
No.
No, the light switch would do that. It would break the connection, which would turn off the light. So rather than programming in the player controller the logic to turn lights on and off, you would program it in the light switch, because that's the thing that in the real world would deal with that. And that makes it much easier, because now your player controller doesn't have all this light switch.
Yeah, and if you decide that
Code in
the
it.
game's going to be entirely dark without light switches,
You
then
can just delete light switches,
and
and
that's
now
it.
you don't have all this code sitting there messing things
and there
up.
would probably be an interface called interact, and now instead maybe there are fires or torches that you're
Exactly.
turning on that have their own, logic, and then there are no hard references there in between, or logic you got to delete because you don't want that in your as part of your design.
Yeah, and that's something that takes practice.
Yeah.
It's not the most obvious when you start designing stuff where certain code, what classes this code should go into, but as you build more things and you build more systems, you'll cause your own blockages, and you'll frustrate yourself by your own design decisions, and you'll learn like, oh, that would have been better if I put that over there and approach this from a different perspective. But that's the one that has really helped me grow my programming ability, is to try and think of things in that object-oriented way and put the logic within the thing that does the thing.
And it usually comes with practice, and when you start to scale your game, when
Yeah.
there are more mechanics and more actors that you're interacting
Once
with.
you get to the 6th light switch,
Yeah.
and you're like, oh man, not another light switch. I should have done that a different way.
Yeah. And that's when you go back and you refactor and you learn, and then the next time you come across the same design that you want to implement, if that's at another game jam or you're starting on a new project, then you're like, aha, I remember that last time I had to refactor all of that and it took me half a day.
Yep.
This time I'm just going to build it from like this from the get-go.
And you'll build your programming habits of, you know, naming and commenting and the structure that you build things.
Yeah.
You start to kind of fall into a pattern that works.
Yeah, especially if you're starting out, don't get stuck trying to do it the best way. There's really no
Just
need.
get it to work.
Yeah, it's good that you have in mind that, you know, there might be better ways to do things, but get it to work. Just getting it to work, and at that point, probably immediately you're like, oh, okay, it works now, and I know that I can, you know, improve something over in this part of the code, and then you go back and you do that.
Yeah, don't be afraid to have bad code.
No, really,
The best part of video games is no one can see your code once they're out
unless you
there.
provide them as
Unless
learning.
you provide source code.
Yeah, source code or learning examples.
Otherwise, no one knows. If it works, it works.
They were curious about an example on how to use soft object / class version of variables, or at least explain what they're intended for.
That is a great question. So the problem with blueprints and references is if a blueprint references, say, a material, and you load that blueprint into memory, it has to load everything that it references. So if you load let's say our blueprint has an array of materials that you can use as options for your ball, and you load up one of those blueprints, it has to load all of those materials into memory. And that's called a hard reference. So the soft reference, it adds a little more work for you, because the hard reference, you just load up the array full of the things and you can access them. A soft reference is just a path to that, and then you have to explicitly load that up. So it's a great way if if you've already got a class and you're like, oh no, it references everything.
Mm-hmm.
You can move those over to soft references and only load and unload those when you need them to. So it adds a little more work on the programmer's end to maintain loading and unloading the assets.
But it have a smaller memory impact.
Yep.
Yeah. Are there some certain situations when we should use event dispatchers instead of interfaces? For example, I tend to use event dispatchers when I know that this is an event that I probably want to do quite a lot for. So, for example, the player died.
Mm-hmm.
I like to put an event dispatcher there because, other players, they might want to do something when a player died. For example, display in the left corner, like,
Yep.
oh, player X died. And you might, want to call something on another class and another one and another one. And that's when event dispatchers are great, because you're just generically, hey, I did
Yep.
this. And if you ever down the line in a week, a month, a year, you want to know about when the player died, instead of like throwing an interface call or message to a specific actor, and all of a sudden you have just a line of like 8 interface events and you're grabbing a bunch of references. You can have an event dispatcher there that's just letting everyone know. It's especially useful if you have other designers working on it, and you know that, like, I think they would like to
know when
the player
thing
died, and
happens.
they might want to do some VFX.
Right.
The artist,
Or the HUD guy might want to make do a thing. And that's a great way to look at event dispatchers. It's a great way of telling everything in your project that something has happened. And any of those things can do something if they have been programmed to. Most things in your world won't, but the things that need to, well, hopefully should if you program them right. Interfaces are great when you want to call something generic on a specific actor.
yeah.
So if you're trying to call on a whole bunch of actors, that's great for an event dispatcher. If you're from other programming languages, like ActionScript or whatever, that's more like a listener. So you'd set up your event, and then in your various other classes, you would have listeners that listen for that event. And when that happens, they do something. Whereas the interface is more a tell. I want to tell this one thing to activate. And then direct communication casting is when you want to do something specifically for another actor, or you want that actor to do something for you.
That's great. We do have a few more questions that are in the same vein, but I would really recommend watching Zach Parrish tutorial on Blueprint Communication. Go to YouTube, Blueprint Communication, because we're actually out of time.
Oh no.
Yep, that was the
Aw.
stream. Yeah, we're not gonna see each other ever again.
I know.
It's the last
If only
one.
we sat close to each other.
Yeah, like maybe almost right next to each other. We can keep talking about all these things.
Oh, and we will.
Yeah. If you have any more questions that are maybe not covered in the Blueprint Communication tutorial or anything else that are related to what we talked to about today, please hit us up on the announcement post on the forums.
Yep.
I guess I will definitely invite you again because I think this is valuable.
Yeah. Hopefully, as your game gets further along and we tackle some more of these kind of
Oh yeah, they will come
kind
up.
of common like learning hurdles. We'll jump back on the stream and show
Revisit
everyone
it.
how we figured them out.
Yeah, maybe even how we'll take all of this and then we'll actually make it work in a networked environment. I'm not promising anything, but that's where I'm trying to take it. And I have done it before, but this time I'm not going. I don't have a, this is not a project that's going to be a game. It is just entirely to learn these things. And so what's nice about that is that you don't have to like, oh, it's got to ship. I got to finish this. There's a deadline. There's none of that. It's just trying to make it as good as it possibly can be, and as easy to pass over to someone else so that they can understand what's going on, and using everything that exists in Unreal.
You can hand it to Tom, and he can do a Thursday stream on it.
Precisely, because that's literally what happened this week. And so, with that in mind, if you have feedback for us, please make sure that you fill out our survey. It should be linked in chat in just about a bit here. If you enter your email with the survey, you enter into a T-shirt sweepstake, and so we'll send a T-shirt out to one of the few who filled it out.
With Unreal logos.
We love to do this kind of stuff online, but we also have our user groups around the world. So there are, I think, over 120 meetup groups. There might be one near you. And if you'd like to find out, you can go to our webpage, unrealengine.com, and look at our user groups page there. And there's actually a nice little map where you can see locations. If there's none near you and you would like to create one and actually host one, send us an email to community@unrealengine.com. And we'll start a conversation and fill you in what that would be like. If you have any questions about it as well, just make sure you hit us up. Now I'm just umming a lot here. My mouth's dry. We're about to end, hour and a half plus in. We do have all of our online communities, forums. There's a community-run Discord that's fantastic. A lot of people are helping out there. I learned a lot a few years ago from people helping me out there. It's a good resource. Make sure you post. I would suggest when you have a question there, make sure you post it publicly because you never know. Even if someone answered a question earlier and they seem to know the question, what you're answering, the value about a public forum is that other people can see the questions and the answers and the conversation that's going on, and they can glean and learn so much just from seeing two other people, one with a problem, one with a solution. They go back and forth, and there's just a lot.
And so often there's more than one solution to a problem.
Yes.
So getting different perspectives and being able to pick and choose to solve your specific problem is really helpful. Because
Yeah, and opens your mind
never
up.
will that tutorial solve your exact problem.
Yeah, it's like, I've done this 5 times. This is the way it should be. That's not always the case. Although it works for you, it might not work for everyone or every project. If you've seen our countdown videos that we have at the beginning of the stream, they are 30-minute videos of working inside Unreal Engine, and then you speed it up to about 5 minutes. Send that to us with your logo, and we might put you on as one of the countdowns for the week. And as always, make sure you follow us on social media. Special thanks to everyone who's making this possible, which is mostly all of you guys. Partners, everyone else who's making Unreal Engine an amazing community to be a part of, and makes everyone be creative. It doesn't matter if you're a musician, developer, programmer, designer. It's just tools to make awesome things.
Right.
So I like to phrase it. And with that said, did you have anything
No, I was
else?
just going to say thank you for having me on this week. It was a ball.
That's great,
And
Tom.
thanks for letting me play with your project.
Yeah, no worries.
And break it.
Break it and fix it.
And fix it.
Yeah, and then we fix it again.
And break
That's
it
how it
again.
goes. All right, everyone. It was great having you. See us next week. We'll be back.
Thanks. Bye, everyone.